Hello, everyone. Um, Thank you for joining us for this webinar on climate risk assessments to improve climate resilience in coastal cities. We hope that by the end of this webinar, the presentations that are given by the experts and the dialogue that we have together provides you with a toolbox for climate risk assessments and a wide menu of options for adaptation, and potentially even some inspirations for those of you that are already doing some adaptation at a smaller scale and would like to scale this up. My name is Nick Tandy. I'm a senior specialist in the water and urban team of the Global Center on Adaptation here at our headquarters in Rotterdam. Let me tell you a little bit about the partners for this webinar. We're doing this work with our regional office for Asia based out of Beijing. And this is an office that was launched in 2019 by the then Premier of China, the Prime Minister of the Netherlands, and the 8th Secretary General of the UN, Ban Ki-moon, who remains at the chair of our board up to this day. The other partners of the webinar are the IPDC, which stands for the International Panel on Deltas and Coastal Areas. This is an initiative of the Dutch Ministry of Infrastructure and Water Management and has technical support from ourselves, GCA, Deltares, as well as Delta Alliance. But we're also doing this with the Ministry of Ecology and Environment of China and Weihai City. And so we thank our colleagues that are up at this time around 7 o'clock in China, as well as those that are up from the Americas, the participants. We know this is early for you. So what do we have in store for you today? We will have these 4 presentations. They will take about 4 minutes each, 15 minutes each, and then we'll allow for some Q&A. For that question and answer segment, we ask you to put any questions and thoughts that you have in the chat, and then we will ask them ourselves. Let me right now move to the speakers for the session. Let me start with Arno Molenu. Arno, let me start by speaking to you directly before the participants. Let me say, as a new resident of Rotterdam since 1.5 years, I am proud, happy, and honored to live in a city where you are the Chief Resilience Officer. This is a beautiful city to live, and I think the resilience strategy of the city has done a lot to achieve that. Arno has led and coordinated Rotterdam's resilience strategies, water management plans, and in his other hats, he's also a global steering committee member for the Resilient Cities Network. He's also to us here at GCA a strategic advisors for our cities work. Arno, we ask you to please share with us some of your experiences in implementing adaptation in Rotterdam. Thanks.
Thank you, Nick, for this very kind introduction. And I hope somebody can put on the screen the first slide.
Oh, thank you. Sorry.
That's Copenhagen.
Sorry. Like, yeah, no. Yeah. Oh.
So we need the Rotterdam presentation. Yes, exactly. Thank you very much. So thanks, Nick and others, to give me the opportunity to share you our experiences on the city of Rotterdam and how we are adapting. Let's move to the second slide. That's okay, because and maybe for the audience, I think it's always good to start with the bigger map, the bigger picture of the Netherlands. Rotterdam, we call the city a delta city, and that's because we are in the middle of the vulnerable part of the Netherlands. 1/3 is vulnerable is below sea level, you could say, and 2/3 that's including the light blue area. and the dark blue area. 2/3 of the country is vulnerable to flooding to a certain extent. And on the next slide, you can see the reason why water resilience will always be on our agenda. Water is coming from all directions. From the sea, from the rivers, we have, of course, precipitation that is changing the pattern, and groundwater levels are changing. But at the same time, we as human beings have been also paving and making the city more concrete. It is a concrete jungle, as we could call it. We are urbanizing, and that is going on, building more houses and high-rises. And that is already creating a lack of water storage. Yes? So, and one example is a lot of canals in the city have been changed and turned into cities, into pavement. And that's, of course, well, from the water perspective, not a good thing. And the next slide shows that, including climate change, it appears that we really have a challenge. Sometimes we do have small-scale flooding caused by high levels at sea that is happening at the same time with the river. Last Christmas, this happened again during the holidays, and for the first time, the storm surge barrier really has to close because of high sea level rises. And sometimes we also have heat waves and longer dry periods. The droughts are also getting more severe. So climate change is there, and we are already facing the impact. And on the next slide, you can see that we are already, well, for over 20 years working on somehow, you could say, water management, and that changed and developed more into water resilience. And slowly it became a climate resilience. And now we're also talking about resilience in a broader perspective, broader than just climate change. So it is a kind of an iterative process that we are going through. I think we are now in the second edition of our climate adaptation strategy, and also our second edition of the resilience strategy. So it is a process, and it is iterative. It's getting more and more integrated, and I think that's the message I want to share with you using this slide. On the next slide, you see that we have been through a specific process. Of course, it is about risk assessment. But we also developed a vision about what kind of city do we want to be and to become, using water as a value instead of as a problem and an enemy. And that has been translated into, we could say, a holistic strategy for the whole city on water and adaptation. And that, in turn, has been translated into a short-term action plan, which we are already implementing for, I think, 15 years now. And a crucial part of this process is the cooperation with the other stakeholders. So from the beginning, we are working together. This is going very fast. We are working together, and I think the strength of the governance is also crucial in this process. On the next slide, you can see this is one of the latest productions in the city. I'm very proud of my colleagues at the water department who were able to produce for each district. We have 39 districts in our city, very detailed maps with I think 25 variables, so you can calculate the amount of maps that we now have on a city scale, but also on district scale. Everybody, it's open source. All the citizens and policymakers can zoom onto the level of a street and a house to find out what are the challenges and what are the opportunities to adapt. So this is a comprehensive story and a long story, so it's better also to have a look at the website, and you can find all these maps. And the next slide shows that the overall framework that we are talking about is we are focusing regarding adaptation on, you could say, 6 themes. Of course, it's about excessive rainfall. It's about flooding from sea and river. It's about heat and drought, etc. We are also identified the 5 ways of opportunities how to include adaptation and improve adaptation in the city, with a set of priorities, but also a toolbox with 260 different types of measures. So this is an important framework that is now being implemented with a specific action plan for the coming years. And we'll also develop the same action plan for the following 5 years. So far a bit about the how and the framework and the process. I will share a few, the next slide please, examples of what kind of solutions we are talking about. But the main thing is, it are nearly all multi-benefit solutions. And I hope we can go back to this rowing track, because that is what I was showing. And this is an example of what can be done, you could say, in the outskirts of the city. I hope you, yes, this one. So this of course is well, not of course, but if you can imagine, this is a rowing track of Olympic size. It is good for recreation and sports, but at the same time it is a 4 million cubic meter water storage for the regional water system, and that is I think iconic for how we try to implement adaptation in our city. And the next slide is something, is an example I think well known amongst maybe the majority of the audience, but just to focus on again, especially in the center, we need more innovative designs, and this is a redesigned square used for sports, and the next slide shows also for theater, for example. And the next slide shows that it is also allowed to overflow. Next slide, please. So the main message here is we are not only investing in bigger sewer pipes. Actually, we really want to spend our money more in redesigning the public space, and to add more urban quality, and at the same time allowing and creating more water storage. So what we call it, we are working on an adaptive and attractive city at the same time. Next slide, please. So another type of solution is, I think, well known, but we have been implementing nearly 600,000 square meters of green roof in all types. We started with the easy ones, you could say, the quick wins, and with the
wait. Oh.
Sorry, yeah. Do you want to say something? Can I continue?
Yes, please. Yes, please.
Okay. So this is what we call, we are creating a second layer in our city, an additional, you could say, landscape, rooftop landscape in our city. And when you do this on a large scale, this can be really you call it sophisticated part, significant part of becoming a more a sponge city, and creating a more adaptiveness in the city. The next slide shows another type that has to do with, you could say, the water safety aspects. This is a huge levee to keep out the water of the river, but in this levee it is also integrated with a long 1 kilometer shopping mall, and on top of it, it is a park. So again, an example of a multi-benefit solution to also to connect, in this case, 2 districts with each other, and to increase the urban quality again. And the next slide shows another type of solutions that we are working on. Next slide, please. And that is what we call the tidal parks. So we are a coastal city with a huge coastline and river, and we identified, but we all are also a port, of course, and that's why we have a lot of, you could say, concrete embankments. That's of course necessary for a port. At the same time, we identified a lot of kilometers that we can transform into more natural embankments. And this is creating new habitat. It is also reducing the velocity of waves. So this can also be seen as a part of becoming a more climate adaptive coastal city, using, you could say, nature-based solutions in this case. And another final type of solutions, just the next slide, is what we call floating urban development. Yes, here we are. And so we are, well, we call it pilots, but I don't think we can call it pilots anymore. We are just developing on a larger scale and upscaling this floating homes and offices and buildings and even a floating farm, etc. And this is not comparable with, you could say, the simple boathouses in the inland canals in the city. This is all on water with a high tide and low tide difference of 1.5 meters, directly connected to the open sea. So we see in this way of developing our Delta city also an opportunity to create additional urban space, you could say, with quality, waterfront, etc. This is a high value place in the city. So next slide shows we are, there's a whole overview of all types of solutions. And the next slide, I think I had to speed up a little bit. We are also thinking ahead, and because we want to invest in more integrated solutions, even more integrated than we have done so far, like this one. So not only developing using our flat roof landscape just for greening the city, but also in combination with the mitigation ambitions that we have. Solar panels are more efficient on a green roof. That has been scientifically proven. So you can invest and use your roofs for mitigation and adaptation at the same time. This is just one example of how you can use your rooftop landscape in a good way. And the next slide shows is an example. That's an artist's impression about the Rijnhaven. Next slide, please. Rijnhaven, where also the floating office of the GCA is located. Yes, here we are. About the master plan of this old port area where we are creating a floating park. And this is one of the big 7, as we call it. This has been announced during COVID to really give the investments and the economy a boost in the city. And all these big 7 projects, and the next slide is also an example, is they all include adaptation. So we want to use adaptation also from an economical perspective to give the city an impulse. This will become what we call the Rotterdam High Line. It is an old railway of a few kilometers right in the center, and it will be transformed also into, you could say, a longitudinal park which will add again urban quality, biodiversity. It is good for the people living in these neighborhoods, and but it will also improve and increase the adaptiveness of the city. And finally, I'm nearly there, Nick. We are also looking ahead into the future. Next slide, please, because we realize that climate change is not only there; it is accelerating. So we are now not only looking at the consequences of maybe 1 meter sea level rise, but also looking at how do we have to look at well, you could say the spatial development of the western part of Holland, including Rotterdam, taking into account maybe 3 meters of sea level rise or even more. What are the consequences of this? How and where do we have to invest? So this is a really I think important thing. Looking far into the future, using design competitions, and this is also something that we have to translate backwards, backcasting to a policy for the short time. And I think interesting also to share with other coastal cities. And then, yeah, of course, we're not doing this alone. I think this is why we have this webinar. It's good to share our stories. So what are the opportunities, but also what are the challenges, and especially regarding, I think, the long-term future and accelerating sea level rise. Some cities are talking about managed retreat, and I think what I would like to propose is to start a working group with some coastal cities to have a dialogue about this. And one of the possibilities is to also use, of course, the city networks that we are part of. And in this case, we are happy to be a member of the Resilient Cities Network. So that brings me to the final slide, the next one, just some concluding remarks. I think it's good for the audience. We can share a PDF of the presentation, of course, but we are, I think, just some final remarks. It is a data-driven approach, you could say, also a holistic approach. It's not just investing in adaptation because we have a problem. No, we want to become an attractive city using climate adaptation. And so we turn it, it's a paradigm shift, you could say. And the ownership amongst all stakeholders is, of course, an important one. But also, I haven't talked a lot about that, but the involvement of the residents, which is done on a specific project in the districts, that is also, of course, really crucial. I think I stop here because I already talked, I don't know for how many minutes, long enough.
It felt like 2 minutes. Thanks very much, Arno. Super fascinating. Super fun. It's fascinating. On the last points that you raised, Arno, in your summary, I'd like to ask you to reflect on those. One was on how the strategy and the implementation are integrated and holistic. My question to you would be, in what way are you then incentivizing when I look at, for example, the multi-purpose use rooftops? It looks to me like a private sector development. Which parts of this work does the city do itself, and which does it incentivize others? And what are your reflections on which incentives are working and which are not, perhaps?
Mm-hmm. A good one, yes, because I didn't include a slide which shows that looking at the area of the city, you could say of 40%, 40% is public and 60% is private. If you want to become a climate adaptive city, you also have to focus on the 60 private part, the 60% private part, and how to convince residents, house owners, and companies and real estate developers. Yeah. So that's in the case of the rooftop. We started with a subsidy, and I think it's still there. And so people are able to get subsidy from the city to develop. It starts with a minimum amount of square meters. I think it starts with 25 square meters roof top, and that's where you can get a subsidy for. But the interesting thing is somehow new architects that are designing new buildings more or less automatically include a green roof. It's not obliged now. It's their own initiative, intrinsic motivation to do this, because they see also that it's increasing the value of their own real estate. But it started with the incentive of a subsidy in this case, and yeah, well, and including the residents in districts. That's done by also giving people the opportunity with a certain subsidy to together green their streets. And so there is also maybe another one. It is a competition between cities in the Netherlands that is called the tile popping competition. And that sounds really crazy, actually, but it happened, and we challenged Amsterdam and to depave and to get as many tiles as possible out of the street, to a certain extent, of course. And this has now became a national competition, and even in Belgium it is now there. So the cities see also the fun of removing tiles from backyard gardens and certain parts of the street. And the city will give you plans to plant your garden. Yeah? So that's also that is not money, but that is physically you can get the plans to green your garden. Just some examples. Yeah.
Thank you, Anu. Really great. I'm going to ask us to move on now. We're going to move on to the second speaker. And our second speaker is Dr. Xianke. She is a specialist in urban resilience and flood risk assessment at the Institute for Housing and Urban Development Studies, IHS, at Erasmus University here in Rotterdam. She has vast international experience in wide fields that include flood risk assessment and management, numerical modeling, and nature-based solutions. We're honored to have you, Dr. Xianke, and we would like to ask you to speak a little bit about methods and tools for flood risk assessment and cases from both the Netherlands and China. Thanks.
Thank you, Nico. Yeah, I'm going to share my screen about the slides. Can you see my screen? Everything is fine? No. Sorry, there's some errors just pops up. I'm going to share my screen now. I hope it works well. So everything is fine?
Yes.
Yeah. Okay. So, yes. So this presentation, I'm going to talk more about the assessment tools and methods with case study and inflation of the Netherlands and Shanghai. So this something I want to start is about the risk assessment approaches. So normally we have the quantitative and the quantitative approach to assess the risk. So as you can see from the right-hand side of this figure, and the quantitative risk assessment will start with modeling techniques to simulate the hazard and to produce the flood maps, and based on the flood maps to assess the potential damage and also some other negative consequence. In the end, it produces the risk curve, and that can help the engineers to calculate expected annual damage that is caused by the flooding. So this kind of information will provide for the decision makers and policymakers and to plan in the next step. And also, we also have the approach of the event tree analysis. So that is more about a determination of the occurrence probability of the one hazard. So, and in the steps of the different the failure events, then we calculate the occurrence probability. And for the quantitative approach, we use the risk matrix approach, because this approach can be used for assessment for the whole cities, for all the different kinds of the natural hazards, and also you can use it for one specific area. And also this approach consider the component of the risk of the frequency and impact, and indicator-based approach as also consider all the elements of the risk and select some indicators for these elements and assign the score and weights by the expert judgment, and in the end we calculate the risk index. But in the next presentation, I'm going to focus on the quantitative analysis. But first, yeah, there is just an example to show the risk matrix we can use to further inform our decision makers by assigning the scores for the likelihood and impact. These are the two important components of the risk. And in the end, we get the risk score, and we can put a label for the rating from the low to very high risk. So for the quantitative analysis, so first we just follow the hazard modeling, exposure, vulnerability assessment, and then we calculate the risk. So in the first step is to calculate the occurrence probability of the flooding. In this case, so we calculate based on the long-term series of the hydrologic data, so we can calculate the occurrence probability of the one water level, and then we produce the flood maps based on the hydrologic model, and the flood maps can provide information about the inundation extent and maximum inundation depth, etc. And for the damage assessment, so we use some GIS data, so to identify how much population and economic assets will be exposed under these kind of the events. And then we based on the vulnerability curve to calculate how much potential damage can be caused. So, and in the end, calculates the risk. So what kind of data we require for this kind of the quantitative risk assessments? Start from the hazards. So we need to use the statistical model. So that is usually based on the long-term series of the hydrological data or the meteorological data, and to identify the different return periods of the flood events. And we use this kind of data as the input to put into the hydrologic model and hydrodynamic models to calculate the rainfall runoff and also the water level in the river and water level in the sea. So some very popular software we can use here in the Netherlands is Depth3D and D-Flow Flexible Mesh. And so back 1D, 2D, and in some other countries like in USA we use Cross, and also in Denmark we use Mach 21. So there are so many alternatives that we can use to help us to assess the hazards. And for the vulnerability, that is more about the we use the vulnerability curve. That is the typical curve, show the relationship between the floods characteristic. In this figure, it shows the water depths and the potential damage degree or absolute damage value. So these kind of the data we can get mostly based on the expert judgment, and we also can collect some historic flood events records to produce such kind of the vulnerability curves. And for the exposure, so that is more about the GIS data, so population map, social economic map, land use maps. These kind of maps can help us to identify how much elements at risk will be exposed. So for the hazard modeling, so we take the coastal city as the example. So like Weihai, it is frequently affected by the tropical cyclone. So here in China, we call it typhoon. So the typhoon usually brings the storm surge and wave, and also simultaneously bring a lot of rainfall here. And so these will cause high water levels and also the failure of the sea dikes, and overtopping discharge in the coastal areas, which eventually cause the flooding inland. And also the rainfall will cause the high river discharge, and that is a very typical problems in the delta areas. It's always face more than 2 flooding sources at the same time. So there is a high river discharge and also the storm surge coming from the sea. And the high river discharge also sometimes blocks the drainage. So it significantly undermines the drainage capacity in the city. So that is the main reason cause the urban flooding in the coastal cities. And there is one example I just want to show you about the routing process. We can use the hydrodynamic models to simulate the flooding. And this example just to show flooding due to a dike breach in Rotterdam, in the coastal areas in the Netherlands, and it shows how the flooding is expands inland, and the colors of the blue, the gray will show the different inundation depths. Okay, and then after we get the flood maps, usually we use the water depth maps, and we calculate how much damage will be caused by that. So like I already mentioned, that we use the vulnerability curves, and also based on the GIS data, we also can produce the damage maps here, which also can provide information for the decision makers and to check how much damage it caused in some specific area. And then we can decide for the next step what kind of measures we can take. And yeah, so for the risk assessments, in the end, there is the result about risk, total risk. So we combine many different events into maps or aggregate damages for different exceedance probabilities. Like here in this figure, there are 3 events occurred with blue dots here. So there is one event real floods with a lot of the damage, and also there is some events, they are frequent floods with little damage. So we can take the integral of this risk curve to get the expected annual damage, and in practice we calculate the area under this graph. So then we also provide some information for the decision makers, how much expected annual damage of the flooding will be caused in this area. So after we get the risk map, and the government will think about to propose some adaptation measures to deal with the flooding. So usually we use the cost benefit analysis to trade off the cost and benefits and to evaluate and prioritize, of course, the list of the climate adaptation options. And this is also important for the government to how to optimize the allocation of the resources. So the question can be answered by the cost benefit analysis is how much should be invested in which adaptation options and at what time to create the highest benefit at reasonable costs and within available budget. And this figure I want to show as the example of the compound flooding in Shanghai, actually a project I did before. So, so when we do the coastal climate risk assessment, we have to take into account the different flood sources that can be occurred simultaneously or subsequently in a short time. And in this case, in Shanghai, it's also affected by the typhoon almost every year, and which causes the high storm surge, and with the possibilities of the occurrence of the high astronomical tide in the coastal areas, and which can cause the coastal flooding and cause the high. And at the same time, the typhoon also brings the rainfall, which causes high river discharge in the upstream. And of course, globally, we are facing the sea level rising challenge. And in some delta areas, there is the problems of the subsidence. So the problems is coming from the different directions and which pose the threats in the future. So now I'm going to talk about 2 case studies. One case is in the Netherlands, Vlies, and so this location is, this city is located in the southwest province of the Netherlands, and it is at the connection of the North Sea and a river Westerschelde. So because of the lateral character of the connection of the sea and the river, and Vlissingen is very vulnerable to the tidal effects and the storm during the winter time. And the flooding can be occurred in the coastal areas, and also sometimes the government also concerns about in the future with the sea level rising, and it causes the urban flooding in the cities. And the local governments, they were thinking about 2 adaptation measures. One is to increase the height of the dikes, and other one is to redirect and store the flood water. So here is the some design ideas about the redirect and use some retention areas to temporarily store the flood water here. So you can see the blue colors. It shows how the water can be redirected into the inland area. And there is the one area with the green land and some parking plots over there. So government thinking they may use these areas to temporarily store the water, and after the flooding, they can pump out the water into the canals or some other waterways. So that is the idea. And there is an example also show the flood simulation and Flick's case show by the dynamics of the inundation depth. So it shows this is also based on the depth-rated flexible mesh, and we produce the inundation depths and to show that. And after that, we got the water depth maps, and for the baseline and 2 scenarios, we just compare them, and in terms of the damage, potential damage, and based on the cost benefit analysis to evaluate the economic efficiency of the 2 proposed adaptation options. So some preliminary damage assessment results here. So according to the Dutch methods, we can calculate how much economic damage can be caused by the flooding. and also how many people will be potentially killed or affected. So here we get some values, figures, and from the economic point of view, we can quantify the potential damage and affected people in a monetary term here, for instance case. So we can use this to compare the different scenarios. So in the end, we get how much damage people affected, and we calculate how much costs will be involved in this, and then we calculate expected annual damage, which can be shown here, but it should be noted that for this kind of approach, we only consider the economic benefits, but there are some other benefits like environmental or societal benefits are not included here, but they are also matters a lot when we make final decisions. And yeah, for the costs, so we also concerned about how much costs initially, and also when we do the implementation, and after that there is a repair and maintenance costs will be involved. So there is just one table shows the overview of the cost and estimates in the Netherlands, and for the dikes and some other measures. And yeah, for Shanghai, the next case is in China. So as Shanghai, as you know, Shanghai is surrounded by the water. So it's at the Yangtze River estuary, and to the east is the China Sea, and to the south is the Hangzhou Bay. To the west, there is the Taihu Lake, which discharges some water through the Huangpu River in Shanghai. So for Shanghai, when the typhoon comes and it causes the high storm surge, and there could be the possibilities to occur the high astronomic tide during that period. And at the same time, the torrential rainfall also causes a lot of the water in the city. So Shanghai is actually facing the compound flooding, and the government is also concerned about the future climate change. And this is a schematization of the Shanghai micro water system. So from this figure just shows how the storm surge at estuary will reverse back the flow direction in the river, and that will be occur with happened at the same time with the high discharge from the upstream. So of course the high water level in the city, and for which also blocks the drainage and undermines the drainage capacity. So that is the big problem in Shanghai, which of course the inundation on the streets. So in this project, we start from the climate model. So we want to stimulate the typhoon. So we use hotline center model to stimulate the typhoon in the past and the future period under the RCP 8.5. That is the most high emission scenario of the climate change. And this slide shows the model results of the trajectory of the typhoons in the past and the future period. So we know these potential typhoons in the model, which will affect our study area, Shanghai. And we use the depth-ready flexible mesh. The left-hand side shows the grid cells we used for the depth-ready flexible mesh, and the right-hand side is some data used like the bathymetry in the sea, and we have to use that to stimulate the storm surge. And some validation results shows that this model can produce has been validated. And for the Shanghai, there is also problems of the climate sea level rise climate change, and climate change also changed the climatology. So it will intensify the typhoon, increase the wind speed and pressure. So it's potentially cause high storm surge in the coastal areas. And the left-hand side is just some sea level rise projections in Shanghai at the end of this century. And the right-hand side is also simulation results just to show that is the potential typhoon will affect the Shanghai. And also this is the rain rate, so potential and the rainfall intensity will be caused in this area. Then we can use this as input to calculate how much inundation in the city. So there are also some simulations about the spatial variations of the rainfall rates we simulated for one typhoon event, and for I have to speed up. And this is the results of the storm surge. So in this model, we can easily get the results and how the storm surge will be caused in the coastal areas of the Shanghai. And then we put this in our model to calculate the finite probabilities of the sea dikes, and then simulates the over inland flood model. And I need to skip this. There is the maps results for this project, for our Shanghai project. So it shows, and these red lines just shows the potential bridge locations in Shanghai, and under the scenarios of the very high intensified typhoons, with the relative sea level rising in the future. So and the other colors just shows the probabilities of the overtopping and of the sea level of the sea dikes, and then we can simulate the inundation in different districts. Oh yeah, so some a simulation I want to show as the Basobak that is the Wanli drainage. So this is just one part of section of the pipeline system in Shanghai, and this is the cross section of the profile for the pipeline and manhole system. And if we just assume all the rainfall water goes into the pipeline, the water can easily flow out from the manholes, like this blue line shows. And we also can simulate how much water on the streets and the different return periods of the rainfall. So my last slide about reflection and discussing with you. So we propose for the coastal areas, if we do the climate risk assessment, we need to develop integrated framework to consider the combined effects of the sea level rise, land subsidence, and increasing tropical cyclone intensity. But this quantitative approach requires multiple data, and the quality of the data also matters. And with the future climate change, at least for the Shanghai case, the relative sea level rise is likely to have a larger effect than the tropical cyclone climate change, climatology change on the dike bridge lines. Thank you so much for your listening, and welcome any questions.
Thanks very much, Chiang. We have a question, I think, from one of the participants regarding the modification of dike height. In fact, I think it's a question that applies to both your presentation and that of Arno. So you can always also provide more detail in the chat. Their question is this primarily for the for mitigation purposes, and does it take into account blue or green infrastructure? Just provide perhaps some generic reflections, because it's not very specific to which part of the presentation it's referring to.
Okay. should answer the question about the blue-green infrastructure. Yes, so yeah, that is a very a popular blue-green scheme or the infrastructure implemented in the city. I think that is like in China we have the smart city scheme, so I think it is quite important to include the blue-green infrastructures. Also, like the others mentioned in Rotterdam, we also have the green roof schemes, and these kind of nature-based solutions can also help with the flood protection and prevention. But from my personal point of view, it's also important to combine with the green infrastructures like the flood defense system, and that is it's effective, but with the purpose of the sustainable development and create a livable cities everywhere. I think combined with the blue-green infrastructures, that is essential.
Right. Thanks very much. There's lots more we could have talked about, but you know, it's a 90-minute webinar, so we're going to move on to the next section. Thank you very much. And now we move on to our third speaker, our third expert, and that is Pele Bogerson. He is a hydrologist and environmental engineer at Sweco, and he has worked on both the technical aspects and the strategic aspects of hydrological assessments, water resources management, sometimes with a specific focus on hydropower and dams. Quite a lot of experience in Southern Africa, including on nature-based solutions and integrating green and grey infrastructure where we just left off, including in some coastal areas in Mozambique and trying to reduce vulnerability of communities there. So we can't, of course, give out your whole experience, Pele, but we're going to ask for you to speak a little bit about nature-based solutions for resilient coastal development. And sorry, I will have to press you a little bit to do the kind of a compressed version of your talk. Thanks.
Thank you very much. I will definitely aim for that. No worries. Okay, so my name is Pelle Bogerson, and thank you for that introduction. I think you covered the most of it. So I used to work for IUCN, the International Union for Conservation of Nature in the Eastern and Southern African region. And there I worked specifically with nature-based solutions and coastal resilience, mainly in Mozambique, Kenya, Madagascar, Mauritius, but a lot in Mozambique. And I was very pleased to hear the Rotterdam presentation about how you are working a lot with nature-based solutions in your context. And so for you who don't know really what is nature-based solutions, I will have a short introduction to the concept so you get familiar with that if you aren't already familiar with it. But first and foremost, I'll just introduce Sweco a bit. Sweco is an engineering and architecture consultancy firm, and we right now, I'm not sure if it's right now, but at least in 2021, according to the annual report, we were the leading architecture and engineering consultancy in Europe, and founded in 1958. It was based on our founder's vision of a combined architecture and engineering company. However, some of the original companies that formed Sweco was actually founded as early as in 1897. And as mentioned, #1 on the European market in 2021. We have 20,000 full-time employees with as many different perspectives. We work in 15 markets in Europe. So that means in 15 different European countries, we do have offices. But we do work in many countries worldwide, but then mostly in specific projects. We do have some offices across the world as well, but mainly we're talking about project export. So we work in specific project for that period. Our 3 service segments in Sweco is buildings and urban districts, it's water, energy and industry, and it's transport infrastructure. And including in that, it's architecture, sustainable buildings, city planning, climate and environment assessments. But then that combined with renewable energy, electrification, efficient logistics and processes, as well as railway and rail-bound traffic design, public transport planning, cycling in cities, and more. So the combination of these 3 areas that's how we work, and in those areas that we work. And now just this short introduction to nature-based solutions for you who are not familiar with it. There's a definition made by IUCN in 2016 that says that it's sometimes shortened NBS. So when I talk about NBS, it's nature-based solutions. Are actions to protect, sustainably manage, and restore natural and modified ecosystems in ways that address societal challenges. Okay, so what could that be? It could be climate change, it could be food, it could be water resources, it could be storms. So in terms of how do we reduce and mitigate disasters, how do we reduce pressure on water resources and on food resources, and how those can be made effectively and adaptively to provide human well-being as well as biodiversity benefits. And the principles of nature-based solutions, or building with nature, that's more or less the same thing, just another name for it, or green infrastructure or natural infrastructure. It is to include natural components in infrastructure design, while we still meet society's needs for infrastructural functionality. And as mentioned, the aim is to recover or restore ecosystems that have been degraded or lost. And this designing with nature-based solutions requires a bit of a different way of thinking, acting and interacting. And as my colleague from Rotterdam said in his presentation, a good example there was using water as a value instead of an enemy. And that is the same thing with the environment, using it for the purpose of infrastructural design instead of just trying to pushing it to the side. And then by including natural components in infrastructure design, you gain flexibility and adaptability to changing environmental conditions. Extra functionalities and ecosystem services can also be achieved. We'll talk a bit more about that. And it can also lead to lower costs on a life cycle basis than conventional engineering solutions, because many of the ecosystems, once they are full grown and provide the protection you need, then they maintain themselves. So you don't have to use a lot of resources to maintain that specific ecosystem. So it's important before we can build with nature, we need to understand the key factors in the formation and functioning of ecosystems. But then that would be up to us as consultants, or it's important for government and city officials to know about it, but it's a process to get to know that. And this is just an example what this would look like in practice. Up in the left-hand corner, we have the original state. We have a forest, we have a mangrove area, we have a river and a wetland. We have a town or a city here, some farmland, and over time that area has become degraded. The mangroves are severely degraded, they're gone, the wetland is gone, more or less, some patches left. And the city is very exposed to increased pressures from the sea, but also from the river upstream. So what happens here in the restored case that, okay, they have restored the mangrove areas, they have restored the wetland and also the forest here, but an important aspect here is that the best approach might in the end be a combined green and gray solution to the problem, as in this example. You can see that, okay, we have the mangrove, we have the wetland, but we do also have a flood wall. And we could also see that example from Rotterdam, where we have these integrated approaches. And that's where our role comes into this. As consultants, we then assess the situation in the urban planning process. And the aim is to inspire holistic solutions, both through overall thoughts, questions, and real examples of the different projects. And here is our example of a coastal city X, the sustainable city by the sea. And I won't go through all of these slides, because what I will do is I'll send you the PDF of this, and it's interactive in the way where you can press yourself around, you just press the buttons, and you can read more about the specific area. So I'll just give some examples here, because just in general, all water in the city and activities in and around them are connected. So that's why we promote, I mean, we need to have an integrated and holistic approach, because these things, they don't happen in silos. They are connected. Often different units, companies, solutions for different areas are needed. Individual interventions are often ineffective and sometimes not sufficient. So instead, we need to take advantage of synergies between these different solutions. And it is important to keep in mind that water, waste, energy flows, they are strongly linked to each other. And properly planned, they affect each other positively instead of negatively. So collaboration between different technical solutions alone does not contribute to a sustainable city, but in design and architecture, it's also important to have all of these integrated. That can make a difference. So for example, if we just press here, you'll have this in Chinese as well in the handouts, but if you go to the English one, you can even press yourself around like this. You can read about what we do in urban planning, and this is examples of how we work in Sweden in these areas. Urban development, wastewater, drinking water. And then we have these specific environmental examples where rivers and streams, I mean, many coastal cities have bodies of water that run through or near the city. And as explained in the previous presentation, models can be used to assess flood risks and then the effects of measures in waterways. And by seeing these watercourses as a natural solution, a nature-based solution to problems, these can have added values to the city. And in natural environments, there's great potential where we can take advantage of nature's own solutions, for example, through flood and erosion protection in the coastal areas, as well as water quality improvement. And these are then so-called nature-based solutions that provides ecosystem services. And the same thing with stormwater. I mean, in urban planning and development, it is important to designate locations also, once again, such as in the Rotterdam example, to designate locations that are suitable for delaying, purifying, and discharging stormwater. So there you can see this combined green and gray infrastructure solution in reality. And there's a number of examples of projects carried out by Sweco in this presentation as well that I will share, but I won't go through them either. You can read about them yourself. But I will introduce two methods or approaches that we use in our urban design and urban development projects. So the first one is the rapid climate risk assessment. And together with C40 Cities, an organization that joins different cities around the world, Sweco has developed a rapid climate risk assessment, RCRA module. And this module is based on the principles of a simple replicable process that is consistent with IPCC terminology. That means the International Panel on Climate Change. It identifies a wide range of key climate hazards, impacts, and risks. As you can see in the slide here, this is the process you go through: the climate hazard assessment, climate impact assessment, and the climate risk assessment. It is designed to facilitate engagement from relevant city sectors, incorporating multi-sector inputs. So the stakeholder involvement is very important. It makes use of open access, freely available data. And it has an aim also to offer a fit for purpose, non-technical information. So that it'd be easier for stakeholders to understand what's the output of this. And it builds an evidence-based climate change adaptation story for a city. That's also a better way to communicate, so that this can be communicated not just for specific experts or people that are very involved in this area, but also for the general public. And we have an example here. I won't go into detail with this. It's just to show that the example for Quezon City in Philippines, the hotspot hazard map, and how there's been areas that's been identified with flooding and the risk of flooding and the specific locations that are impacted there. And the second method that I would like to talk about is the City approach. And the City promotes a holistic and inclusive approach to sustainable urban development in all its dimensions. It's environmental, sociocultural, economic, and spatial. And it seeks to improve living standards, safety, comfort, and quality of life for all by including stakeholders and citizens in urban development process. And these two things, the rapid climate risk assessment and the City approach, can be combined to integrate the aspects of climate change even more into the approach. And this 6-stage working process can be adapted to many different levels. So the region, the city district, or the neighborhood, or even a single block. So this can then be used to review city plans, to provide strategic orientations for sustainability, to implement existing plans, or to identify necessary institutional, organizational changes that might be needed. And the example of that is a bit of it's from Cafe Eco City in Tangshan in China, where Sweco had an extensive and cross-sectoral assignment in the planning of a new eco city for 1.2 million inhabitants. And that was according to the City concept. And the location of the city is a low-lying area of land that must be protected from extreme high tides. It's built around water with artificial lagoons and an extensive canal system. And the coastal protection is designed as an embankment to the sea after the Dutch model, and with large gates similar to the Thames Barrier in London. And the embankments also create recreational areas with attractive views of both the sea and the city. And as mentioned, these examples, you can read about them yourselves. And with that, I would like to thank you for your attention and giving me the time to introduce Sweco and what we do and how we do our work. Thank you.
Thanks very much for that, Pelle. That was really great and fascinating presentation. If I can draw you to where you started, where you presented that picture of a degraded coastal ecosystem, and then how it was then improved after that, and then the integrated solution with the flood defense system. In your experience and in your reflections, what are the incentives and the disincentives for the scale up of nature-based solutions? Because on paper, it looks really great. In practice, we see much slow uptake.
Yes, that is a very good question. I think the main issue and what we've seen in many projects, and I'm saying that as an engineer, is that there's no engineering handbooks on how you do nature-based solutions. They're coming. There are some that are under development, but it's always easier to go back to what you've always done. And that is a challenge. And also in combination with both with engineers and city officials is that we tend to go back to, okay, but we know that this will happen and how it will look like. And it's easier to design something in concrete because, okay, this is exactly how it would look like. But working with nature is more, you need to be more dynamic and flexible in your approach. So I would say understanding that and being able to use that in your engineering design, that is the main challenge and obstacle right now.
Thanks very much, Pelle. And we will take that as a challenge to us. And hopefully that is an agenda that together with some of the partners that are on the webinar today, we can take forward. I would like to now move on to the next part of the agenda and introduce our next and last, but certainly not least speaker. And that's Luca Leonardson. She is the head of a program on resilient and sustainable city solutions in Copenhagen. She has led various adaptation programs and plans in that city. The Adaptation Plan, a citywide cloud-burst management plan, storm surge management plan, and she's also been involved in the development and implementation of at least what I think is a super ambitious climate action plan aimed at making a city of Copenhagen carbon neutral 2025. That's next year. Luca, it will be interesting to hear how that's going. So with that, we'll ask you to please share. We're eagerly waiting to listen to your talk on climate adaptation in Copenhagen. Thanks.
Thank you very much. Can you bring up my presentation? Thank you. I'll give you a quick overview and I'll be brief since, being the last one, I have to catch up with all the others who've gone over time. Next slide, please. Copenhagen is a coastal city located, we're quite low-lying. Denmark in general is a low-lying country with 9,000 kilometers of coast. We are one of the countries in the European Union that is most at risk from flooding from the sea. Next slide. We have been working with climate change for many years, and we can see that we will have more rain, we will have more severe rains, and we will also have a much higher sea level in the next 100 years. Next. We have also tried to make a risk assessment based on where in the city are we actually facing the most risk of. On the left, you can see the risk from heavy rain, and on the right, it's the risk from flooding from the sea. Next. And again, also looking over time, we can see at the moment, the most imminent threat, that's from rain, but over time, sea level rise will actually also be a very big risk for the city. Next. We've had our experiences with severe weather. This is from a very big cloudburst in 2011, but also lately Denmark has actually seen a number of storm surges, so that it's and also flooding from rain. So it's actually also become a much more a problem that people are much more aware of. Next. And we have worked on adaptation, as I said, for many years now. Starting with the adaptation plan, and there you see the process line for our work on rain, on the cloudburst plan that we have made for the entire city. Next. And looking at how we work on managing rain, it's very much about creating a parallel infrastructure to our existing sewer system, because based on the fact that we cannot expand our existing sewer system enough to be able to manage these heavy rains, we need to do something else. And one of the ways of doing that in a dense city is actually to use the existing infrastructure, streets for transporting water, parks for storing water, etc., etc. Next slide. So a lot of this is actually also looking at, I wouldn't necessarily call them all nature-based solutions, but it's very much at least inspired by the way nature works, working on surface projects, coordinating projects, making it greener, and also trying to see how some of the projects can also help with other issues such as urban heat island effect, that is the warming of the city over time. Next slide. And we have our utility that are taking care of all our hydraulic systems in the city in general. And the city and the Copenhagen utility is working very closely together on this in a very close partnership. Next. And we can also see that we actually have a lot of co-benefits of the adaptation. I mean, the same as Arno mentioned for Rotterdam, is that we have this idea of saying, how can we use adaptation to actually create better neighborhoods, better living conditions for people in the city, looking for how can we have more recreational value, more biodiversity, places for people to meet, improve the microclimate. We can have synergy with urban regeneration in the city, better architecture, basically making an attractive city, and also now beginning to look much more into rainwater recycling, as we can also see that water scarcity can become an issue in Denmark too. Next. And these are just some examples of how projects look once they are actually filled out. This is our first one, a small water park where we can store water, but also have created a new meeting place for people in the neighborhood. Next. And this is in a residential area where we are creating sort of a green area. You can see this is very much sort of low key, but it's still with a strong view on biodiversity. Next. This one is one of our major projects, St. Kjeld Square, where we have reduced the paved surface by more than 50%, planted an enormous amount of trees, and created these mini green pocket parks that will actually then not only work as rainwater reservoirs, but also as great places for local people. Next. And one of our newest projects is this one out in Karensminde, where a long stretch of park is actually leading down to a new artificial lake that can store a lot of rainwater in case of heavy rains, and at the same time improving the recreational and value and the biodiversity in the area. Next slide. And the biggest project so far is this one, Enghave Park, where the whole park is basically transformed into a surface reservoir where you can store water in the park up to more than 20,000 cubic meters of water in case of heavy rains. And we've seen it work recently. You can see the wall that keeps the no, it's fine. Go back. Yeah. You can see the wall here around the park that is actually keeping the water inside the park. It just adds to the features of the park when it's not raining. Next. And this one is also a streetscape where we have created 8 sunken gardens where we can store water, but can also actually have a lot of activities when it's not raining. Next, and I think this is the final one I have of these examples. This is a park in a socially vulnerable area where we have also, by creating this park with water reservoirs and so on, have opened the park up to also a wider group of people from the city. Next. Yeah, and being a coastal city, it's really important that we also look at how can a storm surge affect the city. We've had some very close calls recently, but going back in history, we can also see that with sea level rise, Copenhagen can actually face the risk of storm surges with as high as more than 3 meters, which will be devastating for the city. Next. A 1,000-year storm surge will actually cover most of the city and can reach at its highest point almost 4 meters. So you can see that there's really a need to do something. Next. And one of the reasons why we have this risk is that we are located at a sound where water is being pressed in from the north when there's a northwesterly wind. But then if the wind changes and moves back up, that's the arrow 3 you can see here, then you can actually get a lot of water being pushed up very fast through a very narrow passage and then flooding the city and also other parts of southeastern Denmark. Next. And as you can see, this is a challenge today on the left, but if you go 20 or 75 years out in the future, you can see that it's a much larger part of the city that will be flooded in case of a storm surge. And it can cost up to 4 billion euros in damages we have calculated together with our metro company and other stakeholders. The main solution, I mean, we are going, choosing also a more Dutch solution here, is to build an external barrier, because defending sort of the city sort of point by point will be actually more expensive and actually also take away a lot of the cultural history of the city. Next. So we have a storm surge plan that was adopted in 2017. It's an auto protection scheme. We are looking at a 1,000-year protection level, and we will actually have a lot of work being done, especially in the southern part of the city, in planning at the moment. And we will have, I'll get back to what we're doing in the north in a few seconds. Next slide. And that is what we're doing in the north. This is a creation of a new peninsula, a new island that will actually be protecting the city, but can also then work as new housing for many people in the city. Up to 30,000 people can live on this island once it's finished in 2070. Next. It has already started the construction, and it will actually be really important in the protection in combination with a barrier that can be, or a flood gate that can be closed in case of a flood coming in from the north. Next slide. And it's built sort of on the historical perspectives of how the Copenhagen has developed its edges around the city, but then taking into account also nature. Next slide. And as you can see, a lot of the coastal protection here will be based on nature-based solutions. So there will not be like a hard barrier towards the sea, but it will actually be a much more natural solution that can also have a high recreative purpose when it's not flooded. Next slide. There are lots of challenges. I will not go into detail with all of these, but I mean, you can have the presentation, but there's a lot of things both on environmental issues, construction issues, and transport that will actually be a challenge for us in the future. Next. In the south, we have a much higher risk than we do have from the north, and we have a project together with neighboring municipalities, and we are at the moment in the planning process also together with our Ministry of Environment, because we need new legislation in order to be able to manage this problem. Next slide. And there are a number of different solutions here that you can have a string of islands that can be protected, or you can have actually a hard barrier. And the problem with this area is that it is located in a nature protection area. So we are looking to some sort of nature-based solutions in this area in order to be able to preserve the nature values also of this area in the process. But it is an ongoing discussion. How do you do that? Next. And we did a socioeconomic analysis of our whole work on storm surge protection. And it is that there are lots of other things that, I mean, apart from the direct damages, there are lots of things, of course, the physical damage, but there are operation losses, there are inconvenience for lots of people living in the city. And for instance, our metro system is calculated to actually be out of use for up to 2 years in case of a heavy storm surge. So there is a desperate need for us to do something in order to protect the infrastructure of the city. Next slide. So, I mean, the idea is actually working together, and that's also one of the challenges in many cities, is that looking at protection against sea level rise, very often you need to involve other stakeholders, other municipalities, natural regional agencies in order to be able to fully cover yourself in that process, because it's no use if we just do something in Copenhagen and they don't do anything in our neighboring municipality. So we really have to work together. Next. And this is my last one. So I think, I mean, as I think Arno also said it in his presentation, the multidisciplinary collaboration that is really essential, break down silos. All our projects, whether it's about cloudburst or on coastal protection, they have a high complexity. It's difficult, and they are challenging existing practices and legislation. There's a need for innovative solutions, and we have to also look at the hydraulic connections between projects. Also, when it comes to stormwater, rainwater projects and storm surge projects, because we used to think, okay, storm surge, that was in the winter, cloudburst, that was in the summer. But this winter has shown us we can actually also have cloudburst very late in the seasons, October, November. And therefore, we need to actually look much more at the issue of combined challenges here. And I think that was the end. Next, I think that's just, yeah. So I hope I kept it just under time, in my time.
Just in your time. Thanks very much, and we apologize. I mean, we had to rush you there. Look, I mean, this was a great.
It's okay. It's okay.
I have one question for you. We didn't get any on the chat, which is that your second last conclusion is about the complexity of the project, and I wonder, what does it take to communicate that complexity to the political decision makers as one part of the story? And then the second conclusion is about you really need to disrupt, I think is the words that you used. Does that require a patient diplomacy and a bit on a lighter side, or does it require kind of impatient mavericks?
A bit of both, I would say. I think in a lot of this it's also about explaining what you're about to do, and it's also about looking into how can this benefit other agendas. For instance, if you're planning to do something that can impact on transport planning in the city, then you can actually then sort of say, okay, how can this support them in some of the work that they want to do, and so on. So trying to look at what's in it for them, that's one thing. And then sometimes you also have to do as again be challenging in your approach, but in a way where you're not like, you're not supposed to be threatening, but challenging, forcing people by positive thinking to think out of the box. I think that's it. And I think for politicians, it's very much about sort of balancing short and long-term goals, because as I often say, politicians, they have sort of an attention span of their election period, and you need sort of, and if you are able to actually give them results that they can use within their election period, they are also much more willing to take the more long-term decisions because they can see it that way. And many of the projects that we've made in the Cloudburst Plan, they are, and it's the same with some of the water squares in Rotterdam, is that you have these projects that improve the local neighborhood where they are right here and now. And then they might have a very long-term function in securing the city for future climate change. But here now, you can also see, okay, there's a new baseball court, or there's a new park, there's something improved there. And the politicians can go on and say, look, I made this for you.
Great.
And I can see Arno is nodding, so I think he has some of the same experiences from Rotterdam.
Thanks very much for that, Luca. I mean, that really allows us actually, to be honest, to conclude. I'll just make two last points before thanking you all. On the one end, for me, kind of the broad takeaways is we already know that the intensity and the frequency of events are increasing, but also what is increasing is the complexity. And so we saw the examples of kind of the compounded risk of extreme discharges, and also you get then a storm surge. So you've got this complexity of risk, but even with such complexity, and even for whatever city size or city budget, what we also saw from your presentations was that we have at our disposal the tools to assess risk, which are themselves, that toolbox is quite wide, and that was the presentation from Achien. But then the solutions box also in itself is quite wide, and I saw that in all the three presentations from Arno, Luque, and Pelle. And just reflecting on one question that came through from the chat, which was, at what return period should we design the defense system? And the answer to that question is kind of how I conclude as well, which is that has to make economic sense in the location where the defense system is being put. So we've got increasing complexity, we've got some tools that can address that, and we've got a solution box that you can match to your own context, whichever city you are in terms of the economy of that city. I want to thank you all very much, starting in reverse order with Luque, and then going to Pelle, Xian, and then Arno for some really, really fascinating presentations. I know that the participants asked if they can have them. If that is okay with you all, we would ask our team to do that. For our team behind the scenes, who do a lot of work to kind of coordinate this, thank you all, colleagues, and to our partners of the event. And we look forward to having the participants again in future events, wherever you may be. For those that are still to have breakfast in the Americas, those of us that are in offices here closer to GMT, and then those in the East that now need to have dinner and maybe go to bed. Thank you very much.
Thank you. Thank you, Nick.
Thank you very much. Bye.
Thank you. Bye.
Nice day. Bye.
Bye-bye.